Okay, so when you guys are working on this, you've got x is less than or equal to 5, right? Is that, what kind of a line is that? It's solid, but what else? It's a vertical line, right? Because is x 5 here? Is it x 5 here? Is it here? Is it here? All these spots, x is 5, right? So it's a vertical line. Okay, it's less than or equal to, so am I going to be the left or the right of the line? To the left. I'm going to be shading this direction, right? Okay, so what about y is greater than or equal to 3? What kind of line is that? Horizontal. And it's greater than or equal to, so what's that mean? Above or below? Above, right? Greater than, the numbers that are higher? Okay. So the last thing you have to graph is the negative 3x plus 5y is less than or equal to 30. So you've got two ways you guys can do that. You can get the y alone and use the slope and the y-intercept, or you can do it with the intercepts because 3 and 5 both go into 30. So which way do you guys want to see? How many would rather see me do y equals mx plus b? How many want to see the intercepts? Okay, it looks like, okay. I'll do y equals mx plus b first, and then we'll do the intercepts real quick too. All right, so if I rearrange my equation, I get 5y is less than or equal to 3x plus 30, and then I divide everything by 5. So I end up with y is less than or equal to 3/5 x plus 6. All right, so if I'm going to graph that, where do I start? I start at 6 on which axis? The y-axis, yes. Okay, and then using my slope, what do I do? Up 3/5, okay. Or I can go backwards and do the same thing going the other way. Okay, so there's my line. There. All right, so it's less than or equal to, so is it above or below the line? Below. Okay, so where they overlap then is this area right here. Okay. Now, just to show you the intercepts real quickly, what you could have done instead was you could have made your table with your zeros. So if y is 0, what is x? Ryan, if y is 0, then I get negative x. The negative 3x is 30, so what would x have to be? I plug in 0 for y. What do you get? Yeah, negative 10. Okay, now you do the same thing with your x. You make x equal to 0. So what's y going to be? So then you would just plot the 6. So you would plot the 6 and the negative 10 and draw the line that way. Okay? So that's how you graph with intercepts. All right, so you guys all see the graph up there, right? Is there a question? No. It's two separate points. It's not negative 10, 6. It is negative 10, 0, and 0, 6. Well, you still get the slope of 3/5 if you look at those 2 points. You still end up with, it reduces to 3/5. All right, so let's look at what the vertices are for that system. So do I volunteer to tell me one of the vertices, what the points are? Kayla. 5, 9. Okay, what's another one? 5, 3. And there's one more. 5, no, negative 5, 3. Yeah, okay. Okay, so now what I want you guys to do is I want you to take those 3 points and plug it into this equation. So figure out, you're going to get 3 different values for C for each of those points. You're going to plug in 5 for x, 9 for y. You're going to plug in 5 for x, 3 for y. negative 5 for x, and 3 for y. And find out what the 3 values are that you get. Okay, so when I plug in the 5 and the 9, what did you guys get?
55.
What did you guys get?
55.
55? Okay, sounds like you agree on that. What about when I put in 5 and positive 3? 25. How about negative 5 and positive 3? I got a positive 5. Okay, so this ends up being your maximum, right? And this is your minimum. You guys just did linear programming. Okay? So that's what you guys were supposed to read about last night and take notes on. And so let's talk about the vocabulary that goes with it. You should already have something down in your notes for vocabulary. Do I have a volunteer that wants to tell me what they got for the definition of constraints? Okay. The linear inequalities. Okay. Does anybody have anything else they want to add to that? I'm sorry, what? They form a system. Okay. So if you think about like in real life or like just regular life aside from math, what does the word constraint mean to you? Just think about what does that word mean? Not quite resistance. Being held back. Okay. Anybody have any other idea of constraints? That would be to constrain someone, is to hold them back. So constraint would be the actual thing holding you back, right? The limit or the boundary or whatever, okay? So in math, it's the same idea. They are inequalities that represent limits or parameters for a situation. So, for example, if you're working on a project and I tell you that your costs can't exceed $100, that means you have a limit on how much money you can spend, right? So how would you show that with an inequality? If I use C for costs. It has to be less than 100. Could it be exactly 100? Yeah, it could go up to it. So it would be less than or equal to 100. So that would be a constraint for a situation where your cost couldn't exceed $100. Does that make sense? Okay. All right, so objective function. Does somebody have what they think an objective function is? That one was a little bit harder to come from the text to get that one. What do you think, Maureen?
When you're programming the linear function that is maximized or minimized?
Yeah, so it's what we want to maximize or minimize. So what we're doing is we're taking a real world situation and we're turning it into algebra, right? We're taking a word problem and making it into an equation. And so what that is an algebraic model. It's when we take our real world situation and make it an equation. So it's an algebraic model of a real world problem. And it is what you are trying to maximize or minimize. Okay, so for instance, you might want to maximize your profits. You might want to maximize the amount of space you have for something. What might you want to minimize? If you're in business, what would be something you'd want to minimize? The costs, right? You'd want to minimize your costs, or you want to minimize losses or things like that, okay? Or waste. You want to minimize waste. Okay, so all that linear programming is then is it is using linear inequalities to maximize or minimize your objective function within the given constraints, okay? I'll say that again. It's using linear inequalities. That doesn't look like an eye. Using linear inequalities to maximize or minimize the objective function within given constraints. Okay. And then finally, the last little vocab that went with this was the feasible region. So who had feasible region, what that might be from the reading? Yes. Right, it's just the intersection of the graphs of our constraints. Okay, so there was something that was important about that feasible region, something that we needed it for. Does anybody know what it was that was so important about that feasible region? What's the part that we care about? Raise your hand and I'll call you because I can't understand 5 people. Do you have an idea, Anna? Huh? It is bounded. What we need one that's bounded to use it. But what's the special points? The vertices, right? So what's important is that our maximum and our minimum values occur at the vertices of the feasible region. So it's the whole point of graphing those constraints is because we want to know the vertices of the feasible region. Okay? That's the most important thing about our feasible region. We need to know where the corners are, essentially. Okay? Okay, so let's go through the problem that they gave us in the book. Potter wants to make and sell serving bowls and plates. A bowl uses 5 pounds of clay and a plate uses 4 pounds of clay, and the potter has 40 pounds of clay and wants to make at least 4 bowls. All right, so for this we're going to say that x is equal to how many bowls I make, and we're going to say y is equal to how many plates I make. So when I think about constraints, well, one thing I can see right here, right off the bat, is he wants to make at least 4 bowls. So what do I know about my x values? It has to be greater than or equal to 4. He could make 4 exactly, right? Or he could make more. Now, what about my plates? Am I going to make a -3 plates? No. Could I make 5 plates? Yeah. Could I make 1 plate? Could I make 0 plates? So what's my constraint for y? Greater than or equal to 0, right? So we're not going to make any negative plates, but I might choose to make none. All right, the other constraint that I see up here is that a bowl uses 5 pounds and a plate uses 4 pounds, and all I have to use is 40 pounds of clay. So the total amount of clay I use has to be 40 pounds. Could it be more? Could it be less? Yes. So whatever I'm coming up with here has got to be less than or equal to 40, right? So how could I represent the amount of clay that I use for the bowls? I could take the 5 pounds times how many bowls I make, right? And then in addition to that, I would have 4 pounds times how many plates. Okay? So those are my constraints. So let's go ahead and graph those on my graph here. Alright, so I've got that x is greater than or equal to 4. That's going to be a vertical line here. Greater than means it's going to the right. And I have y is greater than or equal to 0. That's just right along my x-axis there. And it's going up. And then finally I have the 5x plus 4y is less than or equal to 40. So since everything divides nice and easy, I'm going to use my intercepts for that one. So if y is 0, what's x going to be? I get 5x equals 40, right? So what's x? 8. And how about if x is 0, y is 10. So I go to 8 on my x-axis, and I go to 10 on my y-axis. Okay. And then I draw a line between them. All right, and it's y is less than. If I was to rearrange it, it's going to still come out that y is less than. So the region ends up being in this triangle right here. Oops, I went too far with my triangle. No, I didn't. Oh, that was just an arrow. Sorry. My triangle was good. Okay. All right, so there's my region. So my vertices are at 4, 5, and 8, 0, and 4, 0. Okay, those are the points I care about, the vertices of my region. Now, what it said was that the profit on a bowl is $35, and the profit on the plate is $30. So, is this what I want to maximize? Yeah, the whole point is to make money, right? So, this is what I want to maximize. So if it's the thing that you want to maximize, that is your objective function. So the profit is going to equal, how much money am I going to make on the bowls? $35 times how many bowls I make, right? And then the profit on the plates? $30 plus the number, or times the number of plates I make. So I want to check the values for that objective function at each of the vertices. I'm going to check the value of P at each vertex. So I'm going to check it at 4, 0. I'm going to check it at 8, 0. I'm going to check it at 4, 5. So if I plug it into the first one, I have 35 times 4 plus 30 times 0. For the next one, I have 35 times 8 plus 30 times 0. And then I have 35 times 4 plus 30 times 5. So for the first one, I get $140. For the next one, I come up with $280. And for the last one, I came up with $290. So, how many bowls and plates should I make?
4 bowls.
Where was my maximum profit? 4 bowls, right? And 5 plates. Okay? So, any questions? Does it make a little more sense now, hopefully? Are we good? Okay. Alrighty, so that's it for the lesson.